Hello folks, welcome to CodeCrucks. In this video, we will discuss the example of minimization of DFA. Before we start, I recommend you to watch my video on equivalent states explanation. Consider this is the DFA that we wish to minimize. Let us first find the transition table for that. So this is the transition table. This DFA is having 5 states. First, we'll split all these 5 states into 2 groups. Set of all the non-final states, that is A, B, C, D, and set of final states, that is E. So this is called 0 equivalent or P0. Why it is 0 equivalent? Because without reading any symbol also we can distinguish these states, right? A, B, C, D are non-final and E is the final states. We have not read anything yet, but still they are distinguishable. We will call it as a P0 partition. Now we have to check or we have to identify whether A, B, C and D are equivalent or not. If they are not, and if any of the state is distinguishable, then we will split this red group into multiple subgroups. For that, we need to compute one equivalent or the P1 partition of this. To do so, we have to read input alphabets 0 and 1 from all 4 states A, B, C, D. When we read 0 from state A, we are moving to state B, and when we read 1 from state A, we will move to D in given DFA. From B, if we read 0 and 1, we are moving to capital C and capital E, where C falls in red group and E falls in blue group. It clearly indicates that A and B are not identical states. Rather, we will say that they are distinguishable. So A and B will be in different subgroups at the end. C exhibits the same characteristics as B. On input 0, it moves to red group, and on input 1, it moves to blue group. So state B and C are equivalent states, or they are non-distinguishable, and D is also exhibiting the same characteristic. So what we will do is the red group ABCD, we have to split into 2 subgroups. In one subgroup, there will be A only because it is distinguishable from B, C, D. And in another subgroup, we will have B, C, D because they all are same. They are non-distinguishable. So now our partition P1 would look like this: A, B, C, D and E. Now we have to check whether B, C and D are equivalent or not. If any of the state is distinguishable, then we have to split this BCD further. Now we will compute 2 equivalent of BCD, or we will try to partition this, and we will see if any state is distinguishable or not. If it is distinguishable, we have to split BCD. So 2 equivalent we can compute by again reading input alphabets 0 and 1 from B, C and D states. So on reading 0, we are remaining into green state or green group, and on reading 1, we remain on blue group. If we repeat that process for C and D, then it says that B, C and D are non-distinguishable because whenever we read 0, all states moves to green group, and when we read 1, all states moves to blue group, and hence they are not distinguishable. That means they are redundant or they are equivalent. So we can merge them together. Now we will consider BCD as a single state only. So whatever transitions are coming to B or C or D will come to a single state, and whatever transitions were going out from B or C or D will go from this single state. So P1 and P2 are identical, so we have to stop here. Fine. There is no change in PK partition and PK-1 partition. So algorithm holds here, and the final DFA will look like this. B, C and D we have to merge into single state, and the final DFA will have only 3 states, whereas the original DFA had 5 states. So it is possible that DFA might not have any identical state, or it might have a 2 or 3 or 4 or any number of identical states. So that we can easily find out using this state minimization or the equivalency algorithm, and we can find the minimized DFA. So this DFA generates the same language which is generated by the original DFA, and it will be faster because it has only 3 states. It will reduce the redundancy of the original DFA. Thank you. That's it for today, folks. See you in next video. If you think this video was useful to you, then please like, comment and share. Don't forget to subscribe the channel CodeCrucks. Press the bell icon for the notification of latest videos. Stay connected, stay tuned. Thanks for watching. Bye-bye.